Okay, good morning. Today we're going to be looking at how to create something called a Bohr model. A Bohr model is a model of an atom. It shows the protons, the neutrons, and the electrons. And it shows those neutrons in the correct order in the shells. Okay, so when you're looking at the model on your desk right now, that is a modified Bohr model on your warm-up. The warm-up picture is a modified Bohr model, and you will learn how to draw those in a moment. You will also learn how to draw Lewis dot diagrams. Okay, let's take a look at decoding models. I'm going to wait because some people haven't done it yet. Please do that. How many loads of protons are there? Plus it's around. Write it down. Can you change that for me, please? Get it done. Okay, you need to do this, please. If you don't know how to do it, ask me. What? The atomic number of practices. The mass. The mass of the nucleus. You have to have the nucleus. Okay, we'll wait for some people to finish, and we'll wait until they get finished. The rest of you, if you're finished at your table, can whisper. All the people are working. In the meantime, before we go over the warm-up, we do have a student council election to hold. There are 9 names on the ballots. Since there is more than the required 6 now, we do have to have an election. So you will circle 6 names on the ballot. 6 of them. And 6 only. If you circle more than 6, your ballot gets thrown away. Okay? I don't know. Probably answer you. Of course you can. If you don't, well then you're not very smart. Six names only. Hold it. No, hold it. Turn it over on your desk when you're finished. 6 names. You can circle less, but not more. You can look for less, but not more. 6 names. And if you don't want anybody to know who you're voting for, cover your face.
Mr. Mansell, could you please report to Ms. Brown's classroom?
So when you're finished voting, hand it to me, please. Finished? Finished? Anybody else out there Ballots. Circle 6 names. Ballots. 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 Don't vote. Okay, let's go over the warm-up. Do I have everybody's ballot? Okay. How many protons, Sterling? How many protons? There are 6. Very good. You just have to count the plus signs. How many neutrons, Blue Chris? There are 6. Very good. You just have to count them. 3 and 3 is 6. How many electrons, Dylan?
6.
There are 6. You just have to count them. What is the atomic number? Grace. The atomic number is 6. Remember, it's the same as the protons. What is the mass number, Jace? It is 12. Very good. It's the protons plus the neutrons. Why don't we count the electrons? They don't have any mass. How many, this is a new question, how many valence electrons does it have? It has 4. And it's the electrons in the outer shell only. The outer shell only. How many are in that outer shell? So how many valence electrons do you have? You learned something new today. Everybody should be able to do that from now on. How do you find the valence electrons? Outer shell. Very good. Go ahead and put that in your warm-up. And add this to your table of contents. Find a partner. When you're finished. Drawing more models. You're going to learn this, yes, man. Hurry up and go, because you're going to be left behind. You're not going to learn this. Okay, today you're going to be drawing more models, but before you draw them, you're going to be making them with the models in the Ziploc bag. So don't open the Ziploc bags yet. I'll tell you to open it in a moment. So using the equipment or the pieces that you have in the Ziploc bag, we'll be making more models first. And then once you've learned to make them, then you will learn to draw them. And the drawing them is just slightly different than making them with the model. Okay? So add page 16 and you'll get a foldable in a moment after we work with the models. There should be. Open your drawing. You got something on page 16? Not yet. No, 16 should be blank. Okay, and again, this shows you that page 16 should be on the left side of your journal. Okay, and everything on this side would be on the right side of your journal, so it's in order that way also. Okay, so make sure you're keeping up with that, please. Okay, let's take a look at what we're going to be doing. The first thing I want you to do is go ahead and open up your Ziploc bag. Be careful not to get the beads everywhere. Just leave the beads in the bag. Just take out the rings. Okay? Take out the rings. You will also need your periodic table at the back of your journal. First thing I want you to do is lay your circles like this. And this is going to represent the atom. The orange circle represents what, Armando? The nucleus. The yellow circle represents what? Daniel? The first shell in the pink, second shell in the purple, the third shell. Now, tell me, Terry, how many electrons can be in the first shell? 2. Very good. How many can be in the second shell, Annika? 4. Second shell. What was our rule? 2, what is it, Jace? 8. The rule is 2, 8, 8. You need to remember that. It's important when we're going to draw the models. Okay? Does everybody remember it now? Okay. So, I want you to, using your periodic table, create a model of boron. The red beads will represent the protons. The white beads will represent the neutrons. And the black bead will represent the electrons. You and your partner try to make that model of boron. When you think you have it, raise your hand and I will come check. Proton is red, neutron is white. I'll get you one for you got one, right? I'll get you one for your journal. Raphael. Just use this one for now. Yeah. Raise your hand. We got one group done. Having more than worship. How many neutrons do you have? Why? And then we subtract those two numbers. We subtract them and make that 11. 11 minus 5 is 6. 6 what? Those are the neutrons. So you can't have one more. Right? Or a neutron. How do you get the neutron? What do you do those two numbers? Subtract. Okay, you need to reevaluate your neutrons, and you need to reevaluate your neutrons, and you have way too many electrons. How many electrons should you have? If you have only, you don't have the proton ready. So reevaluate the whole thing. Yeah, you only have only neutrons. Right. Okay, if you have, wait, yes. Remember, what do you have to do this? No. Yes. So you have that to 11. 11 minus 5. Yes. You have weight. So, how do you want that? Now, the next thing is fairly well on this, so if you struggle a little bit, everybody pay attention to the board. This is the way it should have been built. We have 5 protons, 6 neutrons. Again, if you didn't know how to get 6 neutrons, you look at the box in the periodic table, you take 10.8, you round it to 11, 11 minus 5 is 6, and we have 5 electrons. Remember, 8, the atomic number of the protons and the electrons are always equal. So we have to have 1, 2, 3, 4, 5 of those. We need to have 6 of those. We need 2 in the yellow and 3 in the pink. And that would have been our model of boron. Again, why that many electrons? Because we have that many protons. Okay, we have 5 protons, so we needed 5 electrons only. The first shell fills up with 2. And then they start filling up like this. And you should also, and I want you to do this with your model now, the 2 in the first shell should be close together and near the top. They like to bond or pair together. Okay? The electrons want to have a little pair. So take the 2 black electrons and put them close together in the first shell. Somewhere in the first shell. They want to be close together. Okay, the same thing here. In the pink shell, these are going to start, and they actually fill in this way. It's like noon, 3, 6, and 9. So an electron would go here, electron here, here, here. The next one would go here. The next one would pair with this one and go here. The next one would pair with this one and go here, here, until that shell is full. And then the purple shell will start filling here, 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 and here. So that it's clockwise also. So 12, 3, 6, and 9. So just get into the habit of doing that. It'll make doing the Lewis dot diagrams a little bit easier later. Okay, everybody make carbon, please. Take your beads off and do carbon. Make carbon. And you're going to take it at the back of your journal. Grass and cocoa. Make carbon. Good. That's good stuff right so far. Doesn't make you understand. You break something? You don't pay no attention? That's right. Perfect. You did exactly right. Good job. That's exactly right. You put your electrons in the right positions too. Perfect. So then you see you're using that 5 Good job. Neutrons. Remember you got to subtract 12 minus 6 is 6. This you count all of that as 12. That would be that number right there. protons, 6 neutrons, 2, and then 4. And your model should look like that. And the electron's going to be spaced out in that direction, okay? Okay, clear the weeds off. One more. Everybody do lithium. Lithium. It's Li on the periodic table. Lithium. Okay, look at lithium again. Well, that's not the bottom. I know, but what is it out? Be careful with that. There you go. Now it's right. Yeah, more neutrons were 4. We need 3 electrons, 2 can go in the first, and then 1 in the second. That's the way your model should look. Questions about that? Okay, please take your materials and put them back in your Ziploc bag, and we'll play with those again later. But we have to move on. While you're putting that up, I'm going to give you your foldable for today. We're going to learn how to draw them. Drawing them is a little bit easier. It's a shortcut. Yeah, keep your bags at the table. Okay, it's enough. It's over. It's over. It's not working upside down. Whatever it is. Yeah. Okay, go ahead and fold it in half. And we're going to do the front cover first. The notes go on the front cover. It's really just a matter of you following along. We're going to draw a Bohr model of carbon. And then we're going to do what's called a Lewis-Scott diagram for carbon as well. And this is where we will get that. Now, I won't move it down until we actually take the notes on it. I will tell you when to glue it down. So, follow along on the PowerPoint here. The first thing you're going to see is that inside the nucleus, it says drawing all those little circles and drawing all the neutrons and all the protons. The way we're going to do this is just put 6p plus and 6 in 0. Okay, so you would draw a nucleus and put p plus in it. Do it now, please. Inside your little nucleus, put p plus and n 0. Now, because this is carbon, how many? In that little circle right there, yes. Okay, it's the little gray circle on your page, right there, right there. And when you're doing a Bohr model, if the nucleus is to give it to you, you just have to draw a little circle. Okay? Now, on 8-man, on the side there, using your periodic table, well, you already know. I'm just going to give it to you because it's written there already. How many protons are there? There are 6. Let me go back one second. Okay. How many neutrons are there? And how many electrons? 6. So the 8th part of 8-man on your little foldable should be 666 all the way down. So fill it in on that little where it says 8-man. The atomic number is what? 6. The protons are, and the electrons are. Very good. Now, using your periodic table, somebody tell me the mass. What is the mass of carbon? 12. So the little m is 12. What was the atomic number again? 6. To get the neutrons, what do we do to those two? Subtract them. So 12 minus 6 is? 6. So when you look at your periodic table, if you have to do 8-man, do it. If you don't have to, you can just remember how to pull those numbers off to draw the Bohr model, do it that way. So I'm not going to force you to do 8-man every single time. Now if you open up your foldable real quick and look, 8-man is always listed for you where you're going to do this. Whether you decide to do the 8-man or not is completely up to you. I would do it for the first few if you're drawing these later, and then once you learn how to do it, you don't have to do the 8-man anymore. Okay? So, look at the front of the foldable again. Now, carbon. Somebody tell me, on the periodic table, what row is it in? Which row? It's in the second. So how many shells do we draw? We draw 2. Since it's in the second row, and if you don't know how to do that, or you were not here, let me see your periodic table. Everybody look up here, please, if you don't know. Carbon is right here. Dylan? Look. You go across, you get to the number on the side. What does it say? 2. And that's how you get the number of shells. So you have to actually draw, and be careful, draw it neatly. You have to actually draw 2 circles around the nucleus because there are 2 shells. So everybody do that now. We're on still on the front. I told you to turn back to the front cover. You draw 2 shells. How long do you want to answer? Try to draw your circles neatly as you can. Okay? Now, according to Aikman, how many electrons do we have? We have 6. How many go in the first shell? 2. So you would draw those 2 like this. And they would go right there. Just put a little circle or a little black dot. They don't have to be very big. And you draw your 2 circles. Okay. Now, we have 6 electrons to go. We only use 2 of them. Where are the rest going to go? The next shell. Very good. So, you have to have how many in the second shell? You can have 8, but we don't need all 8, do we? We only need 4 of them, and they would go like that. That is a Bohr model of the card. You just created your first Bohr model of the card. That's all there is to it. This will become really important when you get to high school, and I can see in chemistry. And you'll need to know how to draw these, because these help you then determine what elements bond or react with one another chemically. So, for example, hydrogen and oxygen stick together because of the way these are arranged. Now, how many can be in this ring? How many could be in? 8. Each one of these wants a little pair. The reason something would come and stick to it is because there's an opening here. And another atom could come over here, and the electron that's by itself with another atom could pair up with this one. And then those atoms would stick together. Does everybody understand? Okay, and that's how chemistry works. Okay, look now at the big capital C there. Okay? You can see I can put one inside of yours. Okay, go ahead and open up your proposal and find neon. I want everybody to, on your proposal about neon, I want you to create a Bohr model for neon. Okay, if you're not sure of that, you're going to have to draw your own nucleus. So it's right here. Right in this blank space, draw neon. Right here. And I've got you started up there. That's where you're going to start. And then you need to fill in the electrons. So it's just right here. And please try to draw your circles neatly. You don't want squares, you want circles. You need to at least draw that and then draw your electrons. Again, how many can go in the first shell? 2. And we need 10 of them, so land, you're supposed to be on your paper, you should be drawing. Red neon right here. Okay, this is what it should look like. There should be 2 in the first ring, and 8 in the second, for a total of 10. Remember, the electrons have to equal the protons. Electrons have to equal the protons. Questions? Okay, Lewis dot diagram. in chemistry. Okay? Now, to make a Lewis dot diagram, the first thing you have to know is the number of valence electrons in an atom. Okay? How many valence electrons are in carbon? Armando. How many valence electrons are here? There are 4. Remember, they're in the outer ring, and there are 4 of them. Okay? So, on the front cover there, 4 valence electrons. When you draw that in, you would draw it like this. There are 4 valence electrons of carbon in the string over, and you would draw it like this. Again, it starts at the top, and then you go 3, 6, and 9. If this one was something else and it had 6 valence electrons, then you put another one here and another one here. We'll practice that in a moment, okay? And we color in the circles. They should be black dots. Black dots. That is called what? Lewis dot diagram. Okay. What do you use for Lewis dot diagrams? The valence electrons. Okay, again, turn back to Neon inside your booklet. And I want you now on the side there where there's the big NE. Create a Lewis dot diagram for Neon. Use the symbol where it says NE and draw it right around there. Okay, they're going to be side by side, not clusters. Perfect, that's exactly right. Okay, so look at your bottom down here. How many valence electrons are there? 8. So you have to draw 8 around it. Perfect. That's exactly right. Okay, you're almost there. Okay, now, you should have 3 at the bottom. So you got 3 down. Okay. There's going to be 2 here, yes, not 3. Okay, it's going to go here. Okay, so then 2 electrons run there. You're watching about 2 examples. Okay. And that's exactly right. Other people's. Perfect. That's exactly right. Good job. Okay. Way too many. That's right. That's perfect. Good job. Chris, that's right. Good job. Yes. Perfect. Matthew. Yes, all. Got it. Did you understand that sort of thing? You were all right. That's right. Perfect. Good job. Okay. These back copies. Three copies. Okay. You can also see the sample here. Look at this. You see how there's 2 up here? So there's 2 here. See how there's 2 there on the bottom? So you put 2 here. See the 2 there? You put them in. Go to the bottom. You put them on the bottom. See those digits on the side. Okay, let me show you the answer. And then I'm going to show you a shortcut how to figure the Lewis dot diagrams out, so that you don't have to first draw a Bohr model to figure out the Lewis dot diagrams. But Neon should look like that for a Lewis dot diagram. Okay? It should look like that. Now, turn to your periodic table. There is an amazing shortcut to help you figure out how many valence electrons an atom has. And I'm going to show you how that works. In order to figure out Lewis dot diagrams, you need to know the what? The valence electrons. How do you figure out the valence electrons? Well, I'm going to show you using it's the numbers on top. What's that? No, it's my button camera. Okay, so let me show you the periodic table. On the periodic table, you're going to be circling some information. So turn to your periodic table in your journal. Okay. Everybody look at the Everybody see it on your periodic table? Circle it, 1A. 2A. Then you have to skip way over here, because the A numbers start up here again. 3A, 4A, 5A, 6A, 7A, 8A. Circle all of the A's. Okay? Guess what those 1 through 8 A's represent? It represents the valence electrons. The valence electrons. So now I want you to label that as valence electrons, please. You can put a little, let me find a pen that will actually write on this. I won't either. So draw a line and write valence electrons. That little number about it. That's not right. You just need a pencil to circle little A's. Now that means boron has how many valence electrons? 3. Aluminum has how many valence electrons? 3. Gallium has how many valence electrons? Carbon has how many? 4. And so does lead, way down at the bottom. So this column now, everything in this column has 4 valence electrons. Everything in this column has 5 valence electrons. Everything in this column has how many? 6. So if I asked you to draw the Lewis dot diagram for oxygen, somebody tell me how many valence electrons oxygen has? 6. Will they look up here? I know it's 6. I'll start here. 1, 2, 3, 4, 5, 6. And there it is. Somebody tell me for sodium in A. It's on the left side of your periodic table. 1. There it is. There's a little cut diagram for sodium. That's simple. That's 1, right? You do. So let's do argon, AR. Find argon. It's 8. Very good. So you start here. Are you ready to watch me? Wayne? 1, 2, 3, 4, 5, 6, 7, 8. Argon. The outer shell has 8. Can any more fit in there? No. Argon never bonds. It never forms compounds or molecules. It will never stick to another element. It's always just found as argon. Same thing with neon, and everything in AA will never bond. Okay? Questions? Okay, your job is to find a partner and begin working on the inside of the proposal. You need to complete the proposal. Please have it done when you come in on Monday. Have it complete when you come in Monday. If you have about 40 minutes, you can be working on that. Those don't follow the rules. They don't follow the rules. We don't need to worry with those. The only one we're looking at something. We need to take a break to the settings. And certainly those are B's. Freddie, do you have your paper out of your phone? Well, he should have gotten, he just didn't look down. He hasn't been out. He got it. I'm talking about the periodic table. Your exit ticket is just to continue working on that until the bell rings. usage for the P plus and N0? Somebody's asking, who's asking?